Okay, second chapter, linear data structure. In this chapter, the first that contains sorting and searching techniques. And the sorting techniques that have bubble sort, insertion sort, merge sort, quick sort, selection sort. Sorting, that is nothing but the ascending or descending order to the elements in your list or array. In searching techniques, that having linear search and binary search, these are the two searching techniques. Searching is a technique of finding an elements from the given data list or a set of elements like an array or list or trees. Searching is one of the technique that used in a list, array or trees. You can search by one elements, or you can search like binary search that have contains middle elements first search and then both sides of middle elements that are searched. But in binary search that have already that is sorted list. It is important. It is a technique to find out an element in a sorted or unsorted list. Sorted is the operation of arranging the records of a table in some order according to the ordering criterion. Sorting is performed according to the key value of each record, and the record are arranged in ascending or descending order depending on the numerical value of the key. The different methods used for sorting are bubble sort, insertion sort, selection sort, quick sort, heap sort or merge sort. These are the 5 different sorting techniques that are used in data structures. Okay. Sorting means you can sort your numerical values in ascending or descending order, or you can sort your string type of values like your name that are also arranging in sorting orders. In the exam, then your numbers are arranged in your surnames. Okay, using these techniques, sorting techniques. Sorting is the process of placing elements from a collection of some kinds of orders. There are many sorting techniques that have been developed and analyzed, and this suggests that sorting is an important area of study in computer science. Sorting is having some techniques that are used in computer science. Sorting is a large number of items can take a substantial amount of computing resources. Means you can compute each and every elements. First element can compare with second, second compare with third, and one of the big elements can first, then second last, second, third last. Okay. Searching the efficiency of sorting elements is related to the number of items being processed. Means how many number of comparisons that are processed, how many elements that are present in the list, and how to solve that problems using the sortings. Small collections, complex sorting methods may be more trouble than it is worth. The elements that are means that is elements that having some number of elements, depends on the number of elements, depends on the their sorting methods that are used in a sortings. Concept of sorting. Sorting refers the operations of arranging a set of data in some given order. A collection of records is called as a list, and where each record contains one or more fields, and the field which contains unique values for each record is known as the key field. The telephone directory can be considered as a list where each record has 3 fields: name, address and phone numbers. Being a unique phone number can work as a key to locate any record in the list. Sorting is the operation of arranging the records of a table in a certain orders. You can see your telephone directories. You can see your mobile number having contents in your mobiles. Contact list, you can see it. you can type A, then you have seen A related data. You can type a B related data, or you can type a number, then you can give the numbers with their name. Okay, using this sorting techniques. There are few first sorting technique, that is a bubble sort, and it is a simple sorting techniques. Insertion sort, it is second, quick sort, selection sort, and merge sort. These are the 5 different techniques that are used in a. The first one is a bubble sort. Bubble sort is an algorithm which is used to sort n elements that are given in a memory. Bubble sort compares all the elements one by one and sort them based on their values. Sorting takes place by stepping through all the data items one by one in a pairs and comparing adjacent data items and swapping each pair that is out of order. In this bubble sort, the first element can compare with second, second with compare with third, third compare with fourth, and one of the elements can sorted format. Bubble sort is an algorithm which is used to sort n elements. Bubble sort compares all the elements one by one and sort them based on their values. Sort them based on their values. It can compare one by one. Sorting takes place by stepping through all the data items one by one in pairs and comparing adjacent data items and swapping each pair that are out of order. Here the example: 21, 10, 15, 88, 95 and 05. This is the list in unsorted numbers. Okay, in the first pass, the 21 compares with 10. 21 compares with 10. Okay, 21 compares with 10. Who is big? 21, and 10 is small. That's why they change the position of 10 to the first and 21 to change their position to the second. Then compare with second elements to the third. Okay, 21 compare with 15. Who is big? 21 is big and 15 is a small. Then the swap the 21 and 15 their positions. 15 is the position to the 2 to 1 position and 21 is 1 to 2 position. That is a swapping of 21 and 15. Okay, then next 21 compare with 88. 21 compare with 88. Who is big? 88. 21 is small. Then that time 21 and 88 there is no swapping. Here the positions is constants. Then next 88 compare with 95. 88 compare with 95. Who is big? 95. 88 is a small. That's why there is no change position in 88 and 95. Next one, to compare with 95 with 05. Who is big? 95. 05 is small. Then swap the 95 and 05. And the first pass after completion, the output is here 10, 15, 21, 88 and 88, 05 and 95. In the second pass, once again same procedure is started here. Compare with 10 to 15. Who is big? 15. That's why there is no change the position in 10 and 15. Same once again 15 to 21. Compare with 15 to 21. Who is big? 21 is big. 15 is small. Okay. That's why there is no change the position in 21 and 15. Once again compare with 21 to 81. Who is big? 88. 88 is big and that's why there is no change the position 21 and 18. Once again 88 to 05. Compare with both of them. Who is big? 88 is big. 05 is small. That's why swap both of the elements 88 and 05. The position of 88 is 03, the position of 88 element location as a 3, and then change with change to the 4, and the 5 is position is the 4 in the array, and that change with to the 3. Okay, once again 88 compared with 95, there is no position or change in this. And final, after second pass, their sorted list is here 10, 15, 21, 05, 88 and 95. Once again third pass, in the third pass 10 to 15, compare 10 with 15, who is big? 15 is big, that's why there is no change the position. Once again same to repeat the procedure, 15 to 21, and then next is 21 to 05, but in 21 to 05, that's the change their positions. The both the elements are swap here, and the output 10, 15, 05, 21, 88 and 95 after the swap 21 and 05. Okay, finally same procedure, 21 to 88 and 88 to 95, and after the third pass the output is here 10, 15, 05, 21 and 88 and 95. Okay, in the fourth pass, once again same procedure is repeated here, 10 to 15, compare with 10 and 15, and 10 and 15 compare, there is no change their positions because 15 is big as compared to the 10. Same next procedure, that is 15 to 05, which is big, 15 is big, 05 is small, and the both of the positions of 05 and 15 are changed, and 05 comes to the location at 1 and 15 is comes to the location at 2. Same procedure follow this in the fourth pass. The fourth pass after swap that elements 10, 05, 15, 21, 88 and 95. In the fifth pass same procedure is repeated here, 10 and 05 that are compare, 10 and 05 that are compare, 10 is greater than 05, and that's why the swap the elements, 05 comes to the 0 location and 10 goes to the location of 1. Same procedure follows 10 to 15, 15 to 21, 21 to 88 and 88 to 95. Okay, and finally after the fifth pass you have got a sorted list, 5, 10, 15, 21, 88 and 95. Okay, and in this process output is here 5, 10, 15, 21, 88 and 95. You got it? How to solve, how to sort the elements. Okay, now the implementation of bubble sort. How to implement a bubble sort using through coding. This is a theoretical sorting. Now you can sort using the implementation. How to implement in C programs this a bubble sort. Void bubble sort. Bubble sort is a function name. This is the array and this is the array size. This is array, integer numbers and integer array size. Okay, in the previous example here the array, here the array 21, 10, 15, 88, 95, 05, that is also called as a list. Okay, and this list having contains 6 elements. The array size is 6. The array size is 6 and the number of elements you can see in that. Okay, here the integer I, comma j, comma temp. These are the 3 variables integer type. For I is equals to array size minus 1. For I start from array size minus 1. What is the array size? Array size is 6. 6 minus 1, 5. I greater than or equals to 0. I is greater than or equals to 0. I minus minus means that array size is 5 Okay, array size is 6 minus 1, that is a 5, means I value is 5. 5 greater than equals to 0, that is this for loop used for number of passes. This for loop used for number of passes. How many number of passes? 5. Okay, 5, first time 5, then second time 4, third time 3, 2 and 1. Okay, in this way. For j is equals to 1, j less than equals to I and j plus plus. If numbers of j minus 1, numbers of j minus 1 greater than equals to numbers of j. What is number of j minus 1? Numbers of j minus 1, that is the number of 0. Okay, numbers of 0. Consider in the example, that is the value is 21 and the second value is 10. Okay, here if the numbers of j minus 1, that is nothing but the number of 0, that is 21, greater than number of j. Number of j means number of 1, means 21 greater than 10. Yes, if the condition is true, and if the condition is true, this is the logic of swapping. This is the logic of swapping. If the condition is true, then use the logic of swapping. Temporary is equals to number of j minus 1. The number of j minus 1 is nothing but the 21, means the value of temporary is 21. Number of j minus 1 is equals to number of j, means number of j, that is the value is 10, to store into the number of 0, and number of j is equals to temporary, that means the temporary value stored into the first position, means 10 and 21 are swapped. The value of 10 is 0 location, goes to the 0 location, and the value of 21 goes to the 1 location, first location. Means the value of both are swapping. The first value goes to the second and second value goes to the first location using this swapping function. Okay, after the value of j is incremented by 1, again 1 incremented by 1, up to 5 locations that is incremented. In this process to be continued up to this fifth or whatever your number array size. Okay, in this bubble sort, fifth passes use, or fifth pass you can use. Okay, to be continued this, and then sorted list. Got it. Analysis of a bubble sort. In a bubble sort, n minus 1 comparisons will be done in the first pass, n minus 2 in the second pass, n minus 3 in the third pass, and so on. So the total number of comparisons will be n minus 1 plus n minus 2 plus n minus 3 plus dot 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 plus 3 plus 2 plus 1. That means sum is equals to n into n minus 1 divided by 2. That means omega of n square. Omega of big O of n square. Big O notation. Complexity. Comparison complexity. Hence the complexity of bubble sort is big O of n square. The main advantages of bubble sort is simplicity of the algorithm. Simplicity of the algorithm, because its code is small, its algorithm is small. Space complexity for bubble sort is big O of 1, because only single additional memory space is required for the temp variable. Single additional memory space is required for a temp variable. Best case time complexity will be big O of n, and it is when the list is already sorted. If the list is already sorted, then the time complexity of your algorithm is big O of n, and in a worst case, that is big O of n square. Okay.